Namaste. I'm Pratisthit Lal Shrestha, Assistant Professor at Kathmandu University, Nepal, and Principal Investigator at Design Lab. So at Design Lab, we are trying to develop technologies and devices that can address specialized issues related to rehabilitation, healthcare, and assistive technologies, especially for countries like this, countries with low resource settings like Nepal. We have limited industries that are working in this field, and very few research are being carried out in universities or research centers to identify issues or develop technologies. Local innovations are done, but very limited and may die out even without reaching the actual users, or as industries either are not aware about it, the innovation, or may not have confidence to use the innovation and a lack of proper validation. Industries have no other choice than to use the technologies that are imported, which may not be designed based on the local requirement. It'll be mostly standardized and off-the-shelf products. So these are a few issues with the device development or innovation in countries like ours. We do develop devices that addresses the local problems, but the issue is with validation and availability of proper resources. This is where global network can come in and help mitigate the problem. For example, we have been working on mechanical prosthetic knee joint with concept of mixed manufacturing technologies, using conventional manufacturing technologies and relatively new digital manufacturing technologies. We have identified the issues, we have tracked the variables, we have designed as per the local need. We did the calculations and prototype it. So this is what it looks like. So some parts are 3D printed, some parts are made using traditional conventional manufacturing process. But now, when we need to validate it, we lack standard testing equipment. So to mitigate this, we could send the prototype to any institute outside our country that has the testing equipment or has the gold standard setup through this global network. Yeah. The device could be validated and then deployed not only in the local market, but also to the countries with similar situation. In this case, in this particular case, UCL and IIT Madras is helping us. Validation of developed technologies is developed devices is one thing, but further developing the device is another challenge, as we need to understand the local need and then the settings where the device will be used. Developing a device to solve a local problem using local resources, man, material, machine, could be one method for sustainable design and development of the device. This is what we are doing with GDI Hub in a project. We're trying to utilize local manpower with local experts and manufacturers to identify and solve the problems. For example, there's a case of diabetic foot with a partial amputation of the foot. We as a university are collaborating with local prosthetic centers, occupational therapists, and manufacturing centers to develop a solution for this case, understanding the user's perspective. We are trying to design a foot with varying stiffness within, depending upon the distribution of the load and need for flexing. Manufacturing this with a conventional method may not be possible, but additive manufacturing and other digital tools may provide more convincing solution that addresses the user's need. So this is what we have been trying. This is the 1/5 scale of stump and the design prosthetic foot. Similarly, this is the 1/2 scale of the foot that we have designed, and it's printed with TPU, flexible material. Similarly, another case is for the amputation of upper limb, palm, a young boy with a dream to drive heavy vehicles professionally. So we are using similar methods to develop a local sustainable solutions for him as well. Further, we are testing the temperature monitoring device, which can be placed within the prosthetic socket, which will continuously monitor the temperature of the part covered with the socket. It's a tiny device. Which can be programmed and record data for 9600 iterations. Which means if we set the measurement gap of 15 minutes, then it will work for 100 days. It will keep measuring for 100 days. Just to test and understand its uses, we have printed a wristwatch band with a slot of the timer in it. And I have been wearing it since past 2 weeks, 24/7. Here we have placed the sensor, and then this is the band. It keeps measuring the temperature of Everest. So this is how we are breaking the boundary between the countries for developing and implementing sustainable local solutions. Thank you. Namaste.